Right. So far we have discussed about principles of networking application. Uh, then what are the different types of architectures? And what are the different kinds of application requirements? And what are the transport layer protocols used? And what are the various application layer protocols? Then we try to understand one of the important application layer protocol called hypertext transfer protocol. And using it, how do we access the web pages? Then what are the two different types of HTTP messages as well as the formats of it. Then we try to discuss about file transfer protocol and then how exactly a file transfer protocol is being implemented. Now let us look at the next important application layer protocol called simple mail transfer protocol, which is used for the application called electronic mail. Then we will try to discuss about one more very important protocol relevant to the web page contents, which is called domain name service. Right. In the electronic mail application, which we are implementing, there are three important components, namely user agents, then we have mail servers, and third and important one, which is simple mail transfer protocol. These three form the major components of an electronic mail. Let's have a look at each of this individual component. Before that, this is the architecture of an electronic mail. You could find various user agents who would like to access the electronic mail facility, then the corresponding mail servers from whom they want to take the service of the electronic mails, and to connect different types of mail servers we are using simple mail transfer protocols. So first let's try to understand about user agent. So user agent is also referred as a mail reader, and what does a person as an access or a user of an electronic mail would do is he would try to compose an mail and edit an mail or to read the incoming mails. Generally, we would have different types of service providers for the mails like Outlook, Yahoo or iPhone mail client. And generally using an electronic mail, either we try to receive the mails from the outside people, which is your incoming messages, or sometimes you will send the mails, which is called as outgoing messages. Right. The second important component of our electronic mail is mail servers. Earlier we were looking about user agents and what are the responsibilities of a user agent. Now coming to the second important component is referred as mail servers. We know that every person who want to access a mail need to register with this one of the mail providers, and each of those mail providers are being provided with mail servers. What does a mail server basically consist of? It contains of incoming messages for the users. For instance, you have been not active on your Gmail and you have been received some mail from the so and so X person. So until you receive and access that mail, that particular incoming mail will be available stored in your mail servers. In the same case, if you are trying to send a mail, so the messages will be queued in the mail server before it is delivered to the intended recipients. And sometimes we people will be trying to send one mail provider to the another mail, like a Gmail to a Hotmail or a Yahoo mail or any other Rediff mail kind of things. In that case, to connect different types of mail servers, we are using a protocol called simple mail transfer protocol. This is used between different mail servers to send the mail messages. So client sending is connected with a client sending mail server, and the server to whom we have been sending is also concerned with one more mail server. Right. So what does our electronic mail basically consist of? Let's have a quick understanding. Similar to HTTP and file transfer protocols, electronic mail also uses TCP transport layer protocol to reliably transfer the messages from the client to the server. And the port number which is assigned for the electronic mail is port number 25. We have seen today that for FTP it is 2021. Similarly for HTTP we had using a port number called 80. For electronic mails the port number assigned is port number 25. There will be a file transfer from sending server to the receiving server. So since it has been using TCP, we are going to have three phases of transfer. The first one is connection establishment, which is called handshaking between the sending mail and the receiving server, and then the transfer of messages. Finally, after the entire transfer, the closure of the connection. So what are the different types of commands or responses or the interactions that happen between the both user agent and the mail server. So the commands which we have been using here in electronic mail is also in the form of ASCII text, and also the responses will be in form of status code, which gives a number, and the phrase, which is the meaning of that particular code. The messages here must be in 7-bit ASCII code. So let's have a simple understanding of how exactly a mail is transmitted from one person to the other person. The person who is trying to send a mail and the person to whom you are intending to send a mail, both of them are referred to as user agents. So in case if I talk about like he is being connected to a Gmail and the other user is connected to other mail service provider like Yahoo. Okay, so let's try to understand how exactly the communication happens. So Alice is the first person who is trying to send, uses his user agent to compose a message to Bob. The Bob's mail ID is bob@someschool.edu, and he wants to send a mail to this particular person. Once Alice user agent has received it, it sends this message to its Alice user mail server. Okay, so first from the user agent of the Alice to the from the user to the user agent, and from the user agent it is transmitted to the mail server of the Alice. Now Alice mail server would try to connect itself to the connection with Bob's mail server. Now we saw that he is using another mail. Based on that the mail ID, they will identify what is the mail server connected, and now this Alice mail server will try to set a connection with Bob's mail server. This is our step number 3, and he tries to send a connection. And when this particular connection is requested, the SMTP client sends Alice message over the TCP. So here in stage 3, the connection is established. In the stage 4, the message is transmitted from user agent to the mail server. Now from the mail server of the Alice to mail server of the Bob. Now Bob's mail server places the message in the Bob's mailbox. Probably at that time the Bob may not be inactive, so he will be not viewing the mail, but it will be stored in the Bob's mailbox. Whenever Bob log into his mail, he will be able to read the message. So these are the different steps which are involved in a sending of a mail from one person to or one user to the other user. Okay, right. Next important factor to be discussed about SMTP is Simple Mail Transfer Protocol uses persistent connections. We have discussed already that persistent connection is a mechanism in which every instead of sending individual object by creating a separate TCP connection, in a single connection multiple objects can be sent. So SMTP implements persistent connections, and SMTP requires the messages to be encoded in a 7-bit ASCII character. This is one of the essential factors. But once we understand what is an SMTP, it's necessary that we compare our SMTP with the HTTP operations. Now we could understand in an SMTP operation, a user agent is trying to send data to a mail server. So there in SMTP we are finding a push operation being implemented. Whereas when in the previous discussion we discussed using an HTTP, we are extracting the content which is stored in the server. So in HTTP in general we will have a pull operation, and both have ASCII command or response interactions, and the status code is also similar in both the cases. But there's one more difference between SMTP and HTTP is in HTTP each object is encapsulated in its own response message. So almost it's like it is implementing a non-persistent connection. Whereas in SMTP, multiple objects will be sent in a multi-part message, where that is the reason why we can have a persistent connection in case of SMTP. Okay. Right. We know the mail message format in general we have been using every day. So as we mentioned, the protocol which has been responsible for this electronic mail message is Simple Mail Transfer Protocol, and the RFC standard for our SMTP is 822, and the standard for text message format. This is what you have, the header line portion followed by the content body of the message. In header line, we know what do we find in our header line? to whom you want to send the mail, from whom you have been sending, then this subject of that particular mail, everything will be mentioned as a part of the header line, and the body will be consisting of the message of the mail which you want to transmit. Now let's have a look at the various mail access protocols which we have been using. So far from our discussion, we could understand one of the critical or the most important protocol related with a mail communication is simple mail transfer protocol, which helps from user agent to the client's mail server, and then from that it forwarded to the receiver's mail server. But here you could find that receiver mail server to the receiver user agent. Along with simple mail transfer protocol, we have few more protocols options called as POP, which stands for Post Office Protocol, and second one is called IMAP. It's nothing but Internet Mail Access Protocols. So basically your simple mail transfer protocol delivery or stores the mails which have been received to the receiver server, and also it is used to retrieve the mails from the server. Whereas your post office protocol, this is used for the authorization, whether you are the actual user of that mail, whether the credentials are matching or not, everything will be verified by post office protocol, like your sign-in page. The next one is Internet Mail Access Protocol, which is actually used for including some more features beyond what is provided by simple mail. It includes features like manipulation of the stored messages and so on. And to make all this mail applications work, we are using a protocol which we have already learned, which is Hypertext Transfer Protocol, which will give us the access for the various mails like Gmail, Hotmail, and so on. As we mentioned, the post office protocol is related with the authorization of a user. What does generally this POP protocol consist of? The first one is called as authorization phase. For instance, you are trying to access your Gmail on a desktop or a laptop. You try to enter the particular mail web page using that HTTP link. Once that particular mail page opens, then it will try to ask you to type your username. Now here you are trying to declare the username, and if it is matching with the records of it, then it asks you to enter your password. Generally, in case if there is no error in that, it will be providing you the access. But in case if there is an error in the details entered, you may get an error. So the transaction phase, generally it indicates what are the different kinds of things, the applications which you could find here. So there are different types of commands used in this transaction phase. The first one is list. It tries to indicate what are the different message numbers you have. Then you have a retrieve command, retrieve the messages by the numbers, and then you can delete certain messages, and you can quit the server access. For instance, let's first look at the authorization phase. For instance, I'm trying to log into my mail account. So server will ask me to enter the username. Now server is ready to give me the credentials to access, but first thing is I have to enter my credentials. It asks you to enter your username. Now you have entered your username. If it matches with the server database, then it will ask you to enter the password. Now you will enter the password. If it matches with the database, then it approves your request and you will be successfully logged in. Once you logged in, then it will be trying to show you the various list of the mails which you have been received, with each mail given a particular message number. And sometimes you want to retrieve some of the mails which you have deleted kind, so you can do that. Or you don't want a particular mail in your mail list, you can delete that. Or once again you want to retrieve it, you can do it. And then in case if you are done with your access of the mail and you want to sign out, then you can use a transaction phase kind quit. So these are the various types of commands which we use in our using our POP protocol for electronic mail application. So to learn more about POP protocol, as we said, it is used for the authorization phase and then the transaction phase. Previous example was using the commands like download command or delete command, and sometimes we cannot read the email if we have changed the. For instance, if you delete the message from the trash box also, you cannot find once again the retrieving of that particular mails. Okay, so download and keep of the copies, what it means is you are downloading the content, at the same time you will have that copy of the mails in your electronic mails. And POP3 is a stateless across the sessions, that it will not maintain the previous state informations. Then coming to the third protocol which we have introduced, which is called Internet Mail Access Protocol, which is majorly used for providing some additional features for the electronic mail. What it does is Internet Mail Access Protocol keeps all your messages at one place in your server, and it allows the user to organize his mails into different folders. For instance, I have personal mails, office mails, and some business mails, or some spam mails. All things will be categorized into different categories. It keeps the user state across the sessions, what are the names of the folders, and mapping between the message IDs and the folder names. For instance, if it is a spam kind of mail, that will be stored in the spam. So these are the additional features which have been provided by the Internet Mail Access Protocol. So what we have done is learned is what is an electronic mail, what is the architecture involved, what are the three important components, what is user agent, what is a mail server, and then we try to connect with the simple mail transfer protocol. We try to understand the reference of Bob and Alice. Then we try to understand the mail access protocols, which mainly are SMTP, HTTP, then our POP and Internet Mail Access Protocols. Now let's look at the last protocol of our application layer, which is DNS. Right, let us look at the last application layer protocol for syllabus, which is DNS. DNS stands for Domain Name System. Right, so what is Domain Name System and how it is been happen and how it works and how it is useful for us? Let's try to observe. Let us take for simple human beings. What are the different ways to identify human beings? Either by the name, or you find a unique number like Aadhaar number, or it may be some passport number, right? Similarly, in the internet, we are trying to refer different websites with their IP address. But is it that easy for us to reach to a particular website using its IP address? It's definitely a difficult task. So remembering IP address is a difficult chance. So what we try to do is we try to give a generic name which will be easy to understand, which is called as the website name. Now the mapping between the IP address and the website name will be done by protocols like domain name system. So domain name system is a distributed database. What do you mean by distributed database? Is something like total information which is available is tried to be divided or separated into multiple sources where you can find a portion of the information. That is what we call it as distributed database. So based on different name servers, we'll try to divide the entire domain name system. It's an application layer protocol. It's the host name servers try to communicate and resolve the names. No, the core internet function implemented as an application layer protocol. These are the few important points which need to be known about the application layer protocol. So what does the domain name systems, services and architect structure consist of? Domain name system services, if you look at it, will be trying to make a host name to the IP address translation. That is, you are trying to give a website a particular name, and it will be, once you enter that, it will be converted into an IP address. And similarly, the vice versa translations. So we will be having the host aliasing. That is something like what we understand a term called alias, which is nothing but giving up the alternative names. So we will sometimes have canonical names, and the other times we'll have some other alias names for that particular website. So the mail server aliasing, we'll be talking about it. And particularly in domain name system, what we are trying to adapt is we are trying for a load distribution. So we are trying to reduce the load on a particular server by implementing distributed database. So why we are not working on a centralized DNS in case of domain name system? In case of centralized, if there is a failure, the total DNS will be failed. So to overcome that and to reduce the load traffic, and also we are trying to maintain distant centralized database. So the maintenance will be easy. These are the various reasons for which we are adapting for a distributed database. And remember, the DNS is a major function which is trying to map between a host name to an IP address. Right. So we were mentioning that DNS is a distributed database. Let's have a look at how this DNS distributed hierarchical implementation has been done. So first we have a major server called Root DNS Server, which is being associated with the DNS system. And this having the next level of hierarchy related with the functionality of the servers, like commercial servers are categorized as commercial DNS servers, then the organization based DNS servers are categorized as org DNS servers, and education industry sector related DNS servers are categorized as edu DNS servers. So for examples of your commercial DNS are yahoo.com or amazon.com. In case of you talk about organizations, it may be a pbs.org. For education, we have this poly.edu or umass.edu. All these are the related educations. For instance, I'm trying to search for a website called amazon.com. So what will be happened is, once I type this particular HTTP in my browser, so it will be forwarded to the root DNS server. The client queries root server to find this particular DNS server. The root DNS server will be observing that the website is having a amazon.com. So client queries.com DNS server to get amazon.com DNS servers. So from this, it will be routed to the .com DNS server, and from the .com DNS server, we will be trying to find where this particular amazon.com is there, and we'll be trying to get the IP address. So this is how we are trying to route a particular DNS. Right. So how exactly the process of trying to make this domain name mapping to the IP address will be done? So once we enter a particular URL, that will be reaching to the local server. If local server is able to identify that suitable IP address, it will be returning back. Else, it will be trying to contact your DNS root name servers. The DNS root name servers will be contacting the authoritative name servers, like it's whether .com or .org or .edu, and it will be trying to find from different sources that particular IP address of that URL, and then once it finds it, it returns that particular mapping of IP address to the URL to your local name server from which you are going to receive that. Right. So far we were discussing about local root servers and then the root domain servers. Now let's look at the few more types of servers. The next category here you have is top level domain servers. Generally, top level domain servers are related with education, commercial, organization, hero or jobs, museums, and all those kind of DNSs belong to this top level domain servers. For commercial applications, we have been taken care by the network solutions. For the edu category, it will be taken care by educos. And there is one more type of DNS server called as authoritative DNS servers. What is meant by this authoritative DNS servers is when the organizations are maintaining the DNS servers on their own, and the authoritative host name to IP mappings will be done by the organization host itself. This can be done either by the organization itself or the service provider of that particular organization. So as mentioned earlier, the first query which is made by a user will not be forwarded to the other servers, but it is actually forwarded to a local domain name system server. So this does not directly belong to the hierarchy. So what exactly thing happens is each ISP will be having this local DNS. Okay, this is the other name for our local name DNS name server is default name server. When a host makes a DNS query, the query will be sent into its local DNS server, and first it will try to verify from its own cache memory. In case if it is found, then it will be returning by itself. Else, if it is not able to find, then the local DNS server will start acting as a proxy, and this request will be forwarded to the next hierarchy of the servers. Right. Let's try to observe this domain name system name resolution example. Here we have the two different types. One is iterated queries and the other one is non-iterated queries. But let's try to understand exactly the working using a simple example. Now the host at particular cis.poly.ed wants IP address for a particular website gaia.cs.umass.edu. So it's trying to get the IP address of this particular URL. So what it will be done? So once it starts making a query with the local server, the first request from our requesting host will be forwarded to the local DNS server. It will try to find out its cache memory. If it is able to do it, it responds back. Else, if I don't know about this, then the local DNS will be forwarding the request to the root DNS server. In case if the root DNS server is also not able to get the concerned IP address mapping, then it will be informing about this to the local DNS server. Then next local DNS server will be forwarding the request to the top level domain DNS server. If top level domain is having the data about it, it will respond back. Else it will say, so I also doesn't have that information. And after this, we have an alternative DNS server called authoritative DNS server, which have this information, and that will be able to help in mapping that particular information. As we mentioned, authoritative DNS servers are those which are maintained by the organizations or the ISPs of that organization. And finally, this information from authoritative DNS will be forwarded to the local DNS, and from the local DNS, it will be forwarded to your particular requesting host. So here, the local DNS is acting as a proxy. So the role of a local DNS server here will be similar to a proxy server. In iterated query, we could observe that all the requests are made by the local DNS server. It has directly approached root DNS server. If it doesn't find it, directly approach TLD server. If it is not able to give it, then it approaches authoritative DNS server. And every time it was local DNS who has been trying to reach the different types of DNS. But in case of recursive queries, here the burden of name resolution will be on a different case. For instance, first I try to put my request to from the requesting host, I will forward my request to the local DNS server. So whether I need to connect to a particular website, you can provide me the IP address map. For instance, if it is having with Excel, it will respond back, and in case if it doesn't have the information, the local DNS server will forward this request from local DNS to root DNS, right? And root DNS will verify from its database. If it is having that information, it will respond back. Else, the root DNS will be forwarding it to the top level domain DNS. And top level domain will be trying to access it. In case if it doesn't find it, then instead of informing to the root, it will be forwarding the request to the authoritative DNS. Finally, where you are able to get that information. So this is the major difference between iterative and recursive. It puts the burden on the name resolution on the contacted name server. Whomever we are trying to contact, they are not able to give us. They have been asked to find out the next server whether it has any information. So you are having a higher level of loads at upper levels of hierarchy. In case authoritative is having the information related to it, then that responds to the top level domain server. The top level domain server will respond back to root domain server. Root domain will be giving information back to local DNS. Finally, from the local DNS, a particular host which is requested will be able to receive the particular IP address. Right. So any request which is made by the host is forwarded to the local DNS server. Generally, as we mentioned in the prior, that this request will be whenever it receives a mapping of the data, it will be stored in the cache memory so that it could be used for the future purpose. To what extent this information will be available in the cache, it depends on some time limit called TTL. So after TTL, the data which has been stored in the cache will also be expired. So top level domain servers typically cached in the local name servers so that we may not be frequently visiting that TLD. So the frequently visited websites, we can avail the data information from the local servers itself. The cached entries, for instance, I got some data about a particular website, the address mapping, but that may be out of date. It may be have changed, but still in our cache memory, we may be having with the old contents. So if the name host changes the IP address, it may be not known to a local server, and this will happen until your time to leave expires. An update and notify mechanisms are proposed in an IET standard called RFC 2136. Right. So we were understanding about how the DNS caching and the records are being initiated. So what will be the DNS records all about? So DNS records is basically a distributed database so storing resource records. So here the data which is available is in form of resource records, and the format of the resource records is name, value, type, and TTL value. So what is the name and the value, and all this contents depend on the type. What are the different types of DNS records we have is, the first one is called type A, where here the name is the host name and the value is the IP address. This is type A. The next type is type NS, where name is the domain name and the value is the host name of the authoritative name server. Next type we have is type C name. C stands for a canonical name. For instance, the original name of the IBM website is server is .backup2.ibm.com, but the canonical name for it is simple ibm.com. So here the value will be the canonical name. And last one is all about a name which is associated with a mail server, that is called the type MX. Right. So similar to our HTTP and FTTP, also the DNS protocols messages are categorized into query messages, where it's the request which you are sending, and the responses will be referred as the reply messages. And both of them here have almost the same format. What does a DNS request or a query and reply message consist of is identification bits, which is of length 16 bits. Then we have flags, then the questions. And what does this 16-bit identification is all about for query or the reply to that query? The identification bits are included. Then we have the questions, and they have 16 bits used for the flag representation. The different types of flags possible are query, reply, recursion reside or not, recursion is available or not, reply is authoritative or not. That will be mentioned by your flag values. And these are the different questions and the respective answers and additional info which is available in the DNS protocol messages. Right. What are the different types of questions are related with name type fields for the query? Then the answers will be in the record roots in a response to the query, whatever the query which we have mentioned, the name type field, then the record roots in the response to that queries. The records for the authoritative servers will be available here, and this will be the additional information which may be helpful for the further information process. So how do we insert records into our DNS system? For instance, there is a company or a new startup called Network Utopia. They register the name Network Utopia with a website called networkutopia.com at DNS register. Now, as we mentioned about this commercial organizations, it will be taken care by Network Solutions. Now here what they basically try to provide is, they provide the names, the IP address of the authoritative name servers. Here we will be trying to insert two different types of resource record routes. The first one is networkutopia.com, and then the dsnl.networkutopia.com, and this DNS. This is a type A record. There is a second one is talking about the DNSL networkutopia.com with this IP address and the type of that record. The first one is, second one is called a type A record, and we may also have a type MX record for it. Well, let's observe the last topic in our DNS, which is attacking DNS. So how we are trying to face different types of attacks in case of our DNS. There are four different types. The first one is DDoS attacks, and here the bombard root servers with the traffic. The major root servers are being bombarded with the major traffic, so this creates a problem of attacking the DNS. And the local DNS servers generally will be trying to catch the IPs of the top level domains, allowing the root server to bypass, so that we don't want to connect again to the root server followed by authoritative or top level domains. Okay. The second type of attacks we could find is bombard TLD servers. They are potentially more dangerous than redirect attacks, something like when you are trying to direct your page to a particular website, and all of a sudden some of these hackers will try to create attacks so that will be directed towards the websites. This is trying to damage the DNS services. Last one is exploit DNS services for DDoS attacks. sends queries with the spoofed sources, something like spam mails, and trying to create a trouble to the data, right? So these are the various types of attacks which you could find in the DNS. So finally, what we try to understand from DNS is, what do you mean by DNS? How do we map a website address with the IP address? Then what are the different types of servers involved? The local, then we had root domain services, top level domain, authoritative services, and then we try to understand about the further attacks in case of DNS. What is the DNS query and the DNS response message formats? What are the various types of DNS records, which we call it as record roots? Are all our discussions in this particular session. So we discussed about two important topics in this video. The first one is electronic mail and its agents and composition, and the next one is all about domain names. Hope the sessions will be useful, and thank you.